In plain English, a unit substation is Muhammad, my friend, is a transformer. Holly is the high voltage, and Mr. Urbab and DG are the low voltage in one big box. You have a high voltage section, a transformer section. What happened to my?
I'll drink some water, Chad.
Okay, so a high voltage section, a low voltage transformer, and a low voltage section. So if you guys look at this, please, you see where the high voltage section is in here, right here with the disconnect and the fuse. We have the transformer, and we have the low voltage section. This is, Brad, it's called the two main disconnects. Utilities, you can have up to 6 main service entrance disconnects in one location. How many do I have here? I have 1600 amp and 1600 amp and 1000 amp disconnects. So 2 disconnects. We call this as, where's the main for these 2? Where's the main for these? You don't need a main. Can you guys see that these 2 are part of the 6 disconnect rules? I can have 6 disconnects without a main. You go to the 7th, Spencer, you have to put a main. So look how they did it. They have a 1600 amp, a 1000 amp. The 1600 amp is fed from a feeder busway. Now, what is a feeder busway? We're going to talk about these guys as we go. A feeder busway is basically cover bars, phase A, phase B, phase C, and a neutral, completely enclosed into one big duct, if you think about it. So a feeder, the reason why they call them feeder, Brad, because they don't feed, they don't plug in anything. They just go from point A to point B. In between, you can tab into them, but for the most part, they're not meant to be tabbed into. They're meant to go from point A to point B. 0 feet here, all the way 50 feet or 100 feet away. So look how they did it, guys. They grabbed the feeder busway, the busway, which is that cover, all the way to the 1600 amps, all the way, look at the feeder, I'm going to look at feeder number 2 first, 1600 amps. Can you guys see that? And up to this point, they have a T. You can T it. So they have a T, they split. They split the feeder busway, and it went through the plant. It went through the plant. And from this feeder busway, they fed 225 amp plug-in busways. Now, what's the difference between feeder busway and plug-in busway? We have a chapter about it, guys. Feeder busway, it's meant to go from point A to point B without anything plugged into it. You can T, you can branch out of it, but you can't plug into it. It's meant to just take power from point A to point B, a huge amount of power, like 1600 amps. Plug-in busway, guys, 225 is meant to, it's a busway meant to plug in machine as you go. So if you imagine this, each one of these machines, a plug-in busway is at the top. You can plug from this side or that side at intervals of 2 to 3 feet, one plug, and bring an SO cord with a disconnect and feed machines. That's why we have plug-in busways. I want to bring to your attention, guys, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plug-in busways in this manufacturing floor. We are feeding manufacturing floor here, guys. We have never done that, at least with me. It's different than any commercial building because now I have a concentration, Brad, of loads. Imagine each one of you guys is a load that you need to feed. What are you going to feed them? A huge amount of load, as in 50 amp each, 3-phase. You go plug it into the bus ducts, and with an SO cord directly to that machine, tie it to that machine. Okay? So, one more time. The 1600 amp is dedicated for, if you guys look the way they did it, the 1600 amp is a feeder dedicated for the manufacturing floor. They want to feed manufacturing floor. So what they did is they brought it, they T it right in here, and then you have to have an overcome protection device right here, and then they put an overcome protection device, a circuit breaker, guys, and they split and tie into it a plug-in busway from both sides, 1, 2, 3, 4, 5, 6, all the way to 7 and 8. And as you imagine, you're going to see these guys later on. As you imagine, each one of these plug-in busways, you're going to be plugging things into it. Any question, guys, about feeder number 16? Dedicated to the manufacturing floor. Now, can you do it differently? What's the alternative of guys doing it this way? I believe this is the best way of doing it. What if you don't want to go with feeder busway and plug-in busway, Mr. Erbab? Then all these machines that you're going to see later on plugged into the 5 and the 6 and all this good stuff. All these machines, you need a conduit and a wire dedicated all the way to the panel. So it saves in a lot of wires, a lot of labor, and a lot of conduits. That's the only reason why we use it. What's the best location, Mr. Bell, for a plug-in busway? A huge amount of concentrated load in a small square foot, as in manufacturing floor. You have machines everywhere, guys. Number one. And number two, things change, Brad. We're going to change things. You're going to move a machine. If you have a plug-in busway, it's really easy because unplug it, move the machine, bring another machine, plug it in, and off you go. Versus if it's hardwired, then you have to do more work. I guess you can unplug it too. You can disconnect it. But if it's plugging, guys, all what you have to do, de-energize, change, take this machine for service, turn it off, and then disconnect it, unplug it, and off you go with your machine. And bring another machine, plug that machine in, and then push the button and tighten it, push the button, and your new machine is up and running. There is no conduits, wiring, no disconnecting cables or conduits or anything else. Any question, guys, about the plug-in busways? These orange ones, plug-in busways. And you can see, Mr. Bab, since each one of them is 225 amp, I need to put an overcome protection device. Now, anybody can tell me what's the size of that blue here, up to this one? What amp size is this blue here? 1600 amp, thank you. Now, DJ, if I decided to go from 16 into 500 here, what do you think I need here? Every time you transformer, the voltage stays the same. But when you want to go from a 1600 amp, guys, to 500 amp, say I want to go 500 amp here, what do I need? Overcome protection device. You need an overcome protection device. I did not put an overcome protection device right here at this point, guys, because this is 16, this is 16. They're all rated for the overcome protection device ahead of them. Any question, guys, about feeder number one and what's feeding? Feeder number one, guys, is feeding all the manufacturing floor equipment. By the way, this book that you guys have, our industrial book, is following the same like the commercial book, is following a building. And the building is a manufacturing floor building, as you imagine, with a lot of machines that you need to feed. So related to the project that we're doing, very similar to the building that we do. So hopefully that's another way of doing business as we go through. I hope, guys, you look at this one, and that will give you an idea how we're going to design the power in our building, the building that we have, because we have very similar building. We have machines that need to be powered. Actually, ours is more complicated than this because we have two voltages. They have one voltage here, 480. We have two voltages, so we're going to have basically two systems side by side, the top of each other. Okay, so feeder number one, feeder number two is for the manufacturing floor. If you guys look at feeder number two, feeder number one is going around the whole building. Can you guys see that? With a 1,000 amp worth of power and feeding different transformers. I want to emphasize this one here. This is a 75 kV transformer, and it's feeding panel 11, 12, and 13 with 28120. Can you guys see that? That's an interesting situation. I understand why they have feeder number two, because to feed the machines. Feeder number one, I could have gotten away with feeder number one and feed this transformer directly, guys, from the substation. But they decided, since they're doing busways, to go around and feed with feeder busways. So here's one transformer, 28120, feeding panel 11, 12, and 13. Another transformer here, guys. Can you guys see it at the bottom? 50 kVA feeding panel 7 and 8. I have another transformer on this side, guys, feeding 1, 2, 3, and a fourth transformer feeding panel 15, and the last one feeding 4, 5, and 6. 4, 5, and 6. All their panels that they have, guys, are fed from the busway. We don't have to do that. We could have brought conduits to each one of these primary transformer and feed them from the substation direct. But then see how that different way of doing in the commercial, industrial, they're utilizing the busway system, guys. The busway, the feeder busway.
Is there a calculation that you have to use to make sure that you don't overload that thing?
Absolutely. We're going through, guys, the calculation that we're going to be doing next week related directly to how to size this busway, feeder, plug-in, or trolley busways. We're going to be sizing it. I'm going to give you a hint. Not a whole lot different than what we do a panel. So, Okay, any question guys about feeder number one? It's going physically, mechanically, it's routed along the whole building and feeding transformers that feed panels. Transformers that feed panels. Okay, let me check on my guests here. No. All right. Any question guys about this? I want you guys to look at the synchronous condenser here and synchronous condenser. Synchronous condenser, I have two synchronous condensers, guys. Because they're a huge amount of load, I am feeding them directly from, can you guys see that? They're fed directly from bus number 2. Directly from bus number 2. Condenser 1, synchronous condenser number 2. I will talk about the condensers. They use these guys to correct the power factor in a manufacturing floor instead of capacitors. But I want to bring to your attention, guys, the two condensers are fed from bus duct number 2. So here's the what we call a one-line diagram, Spencer. That's your one-line diagram. A substation high voltage 13.8 coming here to a transformer, say 13.8 for 480-120. Two service entrance disconnect means 2. So I don't have a main. And then we fed one of them went and fed mainly the manufacturing floor. The second one went and fed mainly the lights and the receptacles and the supporting areas in this manufacturing floor through another transformer or transformers through multiple panels. Can you guys see where multiple panels are going? Any question, guys, about the system? Here's what your building is, guys. I have a 2-story building in this section. This is my 2-story building office area. This is a manufacturing floor, completely manufacturing floor. I have a boiler. I have an area here where they're having the boiler, putting the boiler right at the bottom of the manufacturing floor. The building, for the most part, it's 1-story building, except at the end, at the end of the building, they took part of the building, stretch it vertically to make a 2-story office, part of it. Any question, guys? Very similar to what we're doing. Really, very, very similar to the project that we're using. Any question about the new concept here, guys, is feeder busways, and plug-in busways. Plug-in busways to plug-in machine, feeder busways to take a huge amount of current, Mr. Bab, from point A to point B. And we're not talking about 50 amps, Brad, here. Look at the current, the feeder. We're talking about 1600 amp. You know how much runs of 500 you need to carry 1600 amps from this point here all the way to this point here? You need a lot of N-tie and J-boxes and so forth. Any question, my friends? Any question about the busway? Let me flip that. So I want to remind you guys with these how it's laid out. So let's go to I want to go directly to the busway. Continue talking about busways. So if you go to E, which E is that one? E2?
I have a question.
Yeah, please.
Real quick.
Go ahead.
Where in this one-line diagram, other than us taking your word for it, does it say that these transformers are feeding 208 or 20?
Yeah, as you go through
Is it
it.
in the book?
It's in the book, yeah, as you go through it. Yeah. Good point. Yeah, because it could be anything. There could be any voltage. Based on looking at it right here, one thing I would do if I was writing this one-line diagram, I would exactly what you said, the voltage. Well, you should be able to, by looking at the one-line diagram, guys, know exactly what you just said. What's the voltage system check? So, okay, where am I here? So if you guys look at this, I colored these. I always like to color them, guys, because I don't know about you. It confuses if you don't color them. It's confusing as is. Okay, so do you guys remember feeder number 1 that we talked about? Ryan, feeder number 1 coming from here. This is the physical location, how feeder number 1 is actually laid out inside the building. You guys with me, you're going to be doing that in Revit. You're going to grab a Revit family that's called feeder, and you're going to stretch that family, guys, from point A to point B. We have a family that says Revit feeder, and you're going to stretch that feeder exactly that we're doing here. So I want to bring to your attention, guys, here's where the substation is. We brought feeder number 2 in here, and we tee it. Here's feeder number 1, went along the building, all the way back to this side. Can you see that? And this is the manufacturing. Now, DJ, what they're showing here, these MA, and MG, anybody can tell me what these are disconnects for the equipment that we're feeding in this manufacturing floor. I want to bring to your attention, guys, the project that we have, our project. You're going to do exactly the same thing. You're going to have a feeder busway going teed. You're going to have a plug-in busway. Look at how plug-in busway 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The orange. Don't look at the pink, please, yet. Don't look at the pink. Just look at the orange. And then we have disconnects on both sides. And with an SO cord and plug, we're plugging multiple machines from both sides. How are we going to do this, Brad and Revit? We're going to have a busway, a family that says feeder busway, coming to another family that says plug-in busway. And next to the plug-in busway, what we did is we put disconnect. We have a lot of disconnect. So physically attach it to the busway right here. And then we make what we did, and then the machine is down. So we wire, or we power. The word is we power the machine to the disconnect to the plug-in busway, and the plug-in busway to the feeder. Remember how we were doing that in Revit? How we powered the load to a transformer and the transformer to a panel? Exactly the same thing. Very easy. Take the machine. We're going to power the machine to the disconnect. Disconnect is sitting right next to the plug-in busway. The disconnect is going to be powered to the plug-in busway, and the plug-in busway is going to be powered to the feeder busway. And the feeder busway is going to be plugged into the switchgear. That's how we did it in Revit. Works smooth, easy, cool. Then you can run schedules for the busway, the plug-in busway, everything. Schedules, unreal. So that's what we're doing, guys. All these are machines fit from a plug-in busway. Is exactly what you guys are going to be showing in our project. Plug-in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why 10? Because that's how they lay out these machines. This layout, the machines in the building are laid out to be covered by 10. Any question, guys, about the plug-in busways? Any question about the plug-in busways? Can you guys see the MB? What's an MB? MB is a type of machine. What's an MC? What's an MD? All these are machine A, B, C, D, and so forth. MF, MO, MN, all these machines, different type of machines. I care less about what they're doing as long as I have owner equipment list with the loads. Remember how the owner equipment list I gave you guys? From there you can size 1.25, size the disconnect, the SO cord, done. I care less about what the machine is doing. It's controlled, self-controlled, has its own controller on it. Any question guys about how they routed the feeder busways and the plug-in busways in the building? So, Bill, my friend, you can anticipate that there is an MA machine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 MA machines right in this area. Otherwise, why would they have a 20 disconnect at the top? There's a 20 MA machines right in this corner. And if you do the math over here, you have 1, 2, 3, 4, 5 G and H machines in this area. Okay? Any question about the plug-in busway and the feeder busway? We could wire each one. Imagine wiring each one of these machines just here, 20 of them, with conduit and wire. Just imagine how many conduits and wires you need to do to bring 20 just in this corner here. I hope that will get you guys to appreciate why a plug-in is very important. Plug-in busway. Okay, and you can do the rest of them. I want to bring to your attention, DJ, these little two things, these are synchronous condensers. I want to just stick one for synchronous condensers are a machine to correct the power factor. That's all. Just remember, they put them because there's so many machines. When you have a manufacturing floor, Camille, your power factor will be completely screwed up because of coils. Every machine has a coil. And when you have just one, in this corner here, 20 machines, and count how many you probably end up with 100 or so machines. So the power factor goes south. To correct the power factor, there are two ways. They either add capacitors, which is one good way of adding capacitors. We're going to add and correct. The other way is to have a synchronous machine, synchronous generators, or synchronous machine, they call it motors, running, guys, and correcting the power factor. Don't ask me how. We're coming to how to size a synchronous generator or synchronous machine to correct the power factor. For the time being, I want you guys to pay attention to these. These are just there to correct the power factor, doing nothing. Okay, pink. What is the pink, Chad? Now we understand what the blue is. We understand what the orange is. What's the pink? The pink is a special type of busway. It's called the trolley busway. What's the difference between a trolley busway, guys, and plug-in busway? It's a busway. Plug-in busway is stationary. You plug in the machine. Unless you unplug it, you cannot move the machine. Trolley busway, Brad, you plug in the machine this way, and you can disconnect the machine, and you can move the machine while connected to the load to a different location. Why would they do something like this, guys? Now, of course, you can't move it everywhere along a track. So if the bus is going this way and I'm the machine connected to a trolley busway, you can move it along the track from point A to point B, and you stop it right in here. Because why would you think we need to do something like this, guys, on the manufacturing floor? The function that machine is doing. If it's a drill or something and you want to move that drill, you're working here, now you're going to move that drill this way and work on that area and come back. You need a system that allows you to move things along a track. In this case, they have, can you guys see trolley? I want to bring to your attention, here's trolley busway A. Can you guys see that? A. Trolley busway B. Trolley busway A, trolley busway B, trolley busway C, and trolley busway D. Why did they decide to have A, B, C, D, 4 trolley busways? That's the need for them. Why did they orient them this way? Now I can move along this track, or along this track, or along this track, or along this track, because of the function of the manufacturing floor. The machines are doing certain things in this area. If I remember right, they're feeding these brads, they're feeding them from the feeder busway, if I remember right. I can't remember if it's feeder or plug-in busway. You can feed them to any way you want. So how am I going to feed this? It's just one piece, guys, one piece. Either you can feed it from the feeder busway, so you have an overcompression device and feeder, or you can feed it from a plug-in busway. And I think they're feeding him from the, if I remember right, the feeder busway. How do they feed them though? Now this is where you can use a conduit and wire. You grab a disconnect from here, and with a conduit and wire, and you go directly to this right here, and you tie it to the plug-in busway at the end of the plug-in busway, so that you can move all the way from end to end. At one end, you have to bring the power to it, right? So we brought the power at, I can't remember, this end, say, this end, and this end of this busway. Any question here about the 3 types of busways? There are 3 types of busways. Feeder busway, it's meant to take power from point A to point B at a huge amps, like 1600 amps. And with minimum interruption. The only interruption in a feeder busway, guys, is a T. That's the only interruption, just to split to go different location. And then you have a junction box with a disconnect, and you take chunk of power and you feed it different locations, like we did, if you guys remember, like we did here. A 225 amp overconduction device fit this section, and so forth. Plug-in busway is easy. It's a small amount of amps distributed through the whole plant to feed multiple motors. Spencer, look at these are 20 machines. Imagine this, the bus, cover bus inside this, or aluminum bus inside this panel. Imagine if you stretch it, guys, all the way through the building. That's what a busway is. Stretching that cover bus to feed multiple loads. Instead of bringing all the loads to one point, now you brought the source of the power directly to the load. Voltage drop is down now, wiring is down, labor is down. Unreal. Any question, guys, about this? Any question? So that's my plug-in busways, my trolley busways, and my feeder busways. Any question? Where are my friends here? Okay. I can't emphasize. Oh, it's there. No. Any question, guys, about the busways, how the busways are related. Just a reminder, Mr. Erbab, you guys are going to do the same thing for me in the project. We have a family, we're going to stretch it and do exactly the same design. So please use this one as a guide, so we know what the busways are. I'm going to go, any question about this, guys? Any question? Okay, I want to flip these and to the second page here, and just go back and look at the building. This is the building that we have, guys. There will be some questions about this building. What, did they piss you off or what, man? Oh,
I've been
man.
training you on it, so.
Okay.
See you tomorrow.
See ya. That's the problem with placing people in the industry, huh? This is the site. Ben, my friend, this is our site. Here's the industrial building, as you can see. A few things I want to mention, guys, they're going to be asking you about. On the site, there's contour lines. Contour lines is one line that connect the point that has the same elevation. Not a big deal for us as electrical, unless you're digging trenches. So I want to bring to your attention, guys, this point here is called benchmark. Everything is measured according to this point. This point is 745.68 feet above the sea level. Without getting into the surveying, guys, who cares? Without getting into the surveying, they take one point in the plant as your benchmark and they measure it based on, and that point will be measured always, the benchmark above the sea level, right? Everybody knows that everything is measured above the sea level. And then everything is this is a relative point. Everything is measured accordingly. So for example, 746, the benchmark, if you guys look at this way, we are at 751. Are we going up or down here? Look at that. We started 745. We're going all the way to 751. So you can see by looking at it that the building from north, what is that? That will be northwest corner to southeast corner. This we're going up. The elevation is going up. Can you guys see that? 51. So who cares, Brad? If you bring your conduits from here, you're going to bring a conduit from here to here. Make sure you start digging at 2 feet. By the time you reach this point, your conduit, instead of 2 feet below ground, it's going to be 2 feet above ground. So pay attention to the contour. Not a big deal for us electrically, honestly. It's a big deal for the mechanical guys when they put their sewer system and water system and all this good stuff. But be aware of these contour lines. So Mr. Abeb, if you see here, 746, everything on this line, that contour line, have the same elevation above the sea level. Okay, so that's what I want to mention. The benchmark, the elevation above the sea level. Also, I want to mention, guys, the light. They have a parking lot light. Can you guys see that? Here's P12 feeding all these lights. I have, they're showing the wiring to P12 also. Another circuit from P12 is feeding multiple P12 here. So they have a bunch of parking lot lights that you guys are going to be doing to feeding the parking lot. So that's my site. They also show, guys, the center line right here, the center line of the street, so you can move for easement. And for a project manager, this is a big deal, guys. When you set the building, you get away from the easement of the building, of the streets and so forth. Luckily, most of the time, we don't get involved too much, Brad, into this one. The architects and the surveyors take care of all the stuff. They put the building for us, and we have no control over how far the building off the street and so forth. But it's really nice to be able to read it, especially when you're putting your conduits and so forth. So here's my benchmark. I care mainly about the elevation of the building. So if I'm putting under, and you only care if you're going underground, outside. Any question, guys, about the contour lines and the benchmark? Look at this one. I have a telephone line, guys, and a T bringing the telephone line to the building. That's what you guys are going to do with Chad too, bringing the telephone line to the building. And I don't see anything. Manhole. There's a manhole right here. Can you guys see that manhole here? Bringing power to the manhole, from the manhole into the building. So it's really, manhole is us. manhole, power to the manhole, from the manhole to the building. We'll talk about this manholes later on, guys, as we go. So here's the north view of my building. The building is only one floor, except at one area, guys, they stretch it to have an office building. You guys are going to have a lightning protection for your building. Here's a lightning protection already designed for you, right at the top of this building. And also the legend, or the site plan symbols and electrical symbols right in here. The symbols for you right in here. Any question, guys, about this? So just FYI, really my main goal is the buses here. Any question about this? Any question? So give you an idea what type of building we're doing. I'm going to flip this one, guys, and talk about the last thing in this project that you're going to be looking at. Now I want to bring you to your attention, guys. So here's the site. We have the riser, or the one-line diagram, and we have the layout of the bus duct through the building. Now this one, guys, is showing the receptacles and the power. Convenient receptacle, Camille, and lights. It's only showing convenient receptacles and lights, and a couple of HVAC equipment that you need to heat and cool the building. So I want you guys to remember, this was bus number 1, the one that went around the whole building. Here's the panel number 14, guys, and here's the unit substation that the bus is coming, feeding panel number 14, panel number 9, can you guys, panel number 10, 5, all these panels, 7, 8, they located these panels along the whole building, guys. That's a good idea. Rather, instead of concentrating all your panels in one closet, then your home runs will be long. Home runs will be long, voltage drop problem. It's a good idea to take your panel right into the middle of your loads and put your panel right there and feed it. By doing that, guys, you cut on your cover for branch circuits and you cut on your voltage drop problem. So that's what they did, guys. Here's P14, and they fed all these lights. Can you guys see all these lights, strings of lights are fed from different panels, So this is P9, here's P9 feeding all these receptacles, P10 feeding these. Now, why did they feed from this panel, not from the other panel? I can give you one hint. You need to feed from the panel closest to the load because of voltage drop and saving on copper and conduits and wires. So P7, you can see here's P7 number here. So you expect these will be fed from P7. If P7 is right here, would you expect these two receptacles to be fed from P10, go all the way to the other side? So obviously not. So these are all the receptacle, inverter receptacle, P8, guys, and the lights, So that's basically really all what you elevator supply to P. So here's an elevator fed for P8, P15. As we go through this project, guys, as we go through this book will be basically walking you through every stage of the building, like the other project did. But really, the main thing I want to mention is this is a different way of wiring. We always, guys, wired with conduit and wire. We are using busways, industrial busways. So who cares, Mr. Bab? When you have a project, they have a manufacturing floor, the first thing come to your mind is say, yeah, we have two examples with Chad Curdy, one of them from a book and one you're going to design, a good example to use for a manufacturing floor. The key word is manufacturing floor, machines. Instead of saying, oh yeah, how many panels I want to go and feed these direct, you are plug-in busways, trolley busways, and Piero busways. These are really the key point for this quarter, using busways. We will size them, guys. We will size them, lay them out in the building. There's so many ways of laying out. I will help you lay them out in our building that we have, but these are really the key point. Any question, guys, about the blueprints? Any question about the blueprints? I don't know where my speakers are. But should we have, guys, 10 minutes, 5 minutes, and then I'll get you. You're gonna see, guys, this is really a nice book, short, down to the earth. Homework, as I said, guys, is gonna be odd and even between you and your partner. So if you guys follow with me at chapter number 1, I walked you kind of through the site plan. We're going to talk about the site plan, determine location of specific items. By the way, part of the homework, guys, is to go to the site plan and find certain things in the site plan. Please do it one time in your life. They ask you about the benchmark. Find the benchmark, and a bunch of other ones. So please do them. Do them for yourself just to know how to read it. I do have the answers as always, and I'd be more than happy to give it to you. Material for the site, materials for the electric site. We have underground wiring methods. I'm going to talk a few things very important about the underground wiring methods. And as always, all these books, guys, start with SI system, always SI system. And calculate metric measurements, I don't know, just a conversion. So I'm going to go to a couple of things, inspect the site plans. As a contractor, a couple of documentation, guys. Here's my take on it as an engineer, and then you become as a contractor. As an engineer, guys, we really don't have a whole lot of say in where the building is located in the lot. This is mostly civil engineers and civil and architects, as well as surveyors. So, but as a contractor, when you go there, the first time you install a system, it's really a good idea to go see where the lot is. Remember when we talked about estimation, how it helps you a lot? Location of the industrial building on the site. How far from the power lines are you? Because you're going to be digging trenches to bring the power to the building from the phone line. So that will help you guys a lot. The site plan helps a lot. Locate the site plan, in my mind, Spencer, has two things. Bringing power, site plan, always bringing power and low voltage to the building. So you need to know which location and how far to bring the power and the low voltage, digging trench basically to bring them, number one. And number two, guys, is the lighting system. You need to locate your lighting system. That's for the most part what we do in the site plan. We bring the power to the building and the low voltage system or systems, and then we put our lights in the parking lot. That's our involvement in the site. Location of underground wiring, manholes. If you have a bigger building, instead of bringing in guys with conduits, now we have a manhole, and you're going to see how a manhole, you bring all the power to the manhole, the cables, and you direct the cables in multiple locations. Another place, guys, that's really interesting too in the site plan, a trailer stores material and tool during the construction of the building. If you're a project manager, the first thing you need to do to go to site plan, guys, where are you going to put your trailer? Among other disciplines. So that's really a good location. Here's an example. You go put your trailer in one location. Hopefully there's a lot of coordination, guys. And then 2 weeks after, they say, oh, by the way, we want to level this area because it's part of the landscaping or part of whatever, surveying the building. So you're going to put it in a location, hopefully, that you do not move your trailer until the end of the project. So a couple of things to remember. A couple of things, guys. The center line of streets, especially if you're bringing, it will show you where the center line of streets, so you can measure things, have a relative point, measure things to your building, especially the power. Power lines and the center line of street can be located in the building. Site improvements. Property lines. Property lines is a big deal, guys. Really, I don't like too much to emphasize it, but property lines is a big deal for us in terms of power, bringing power and low voltage to the building. That's all what we have. Another location, another important thing to me when we come to the site is, that's a lot of people ignore it, guys, design-wise, is the lighting spill over of light. So you need to go take the site, do your lighting calculation, and make sure you're not throwing too much light into the neighbor's yard, or into, that's a big deal, knowing where the property lines are. So which we take the site plan, right? Remember how we guys ran a foot candle calculation on the parking lot? We never paid attention to the spill of the light, but you really can expand the calculation zone, and it will tell you what your neighbor's yard is going to see, how much foot candle that your neighbor yard is going to see. If you just expand, we never did that because it's not a big deal, well, for us, but you really, all what you have to do is just a calculation zone, expand the calculation zone behind the fixtures, and it will tell you what's the foot candle for that's going to be on these average and minimum for these fixtures. Symbols, guys, we have tons of symbols that we're going to be using. This is a few of them, and that for this particular project. I want to see the bus duct is located, but when we get into them, so that these are the symbols that they're using in this project. Contour lines. Mr. Abeb, we said when they do the smarter than Chad, they put a contour line from here to here, and they put the elevation 744, and this is 744. So any point on this line, guys, is actually 744. 744. So that's basically what the contour line. Who cares? If you're digging a trench, it's a big deal. Other than that, for us guys, not a big deal. Trenches must be provided with enough depth. See what I mean? So if I have to dig a trench from here to here, guys, this point to this point, and look at this. This is 700. This is 750. This point is 750, and here's my start point, and this point is 740. Can you guys see? And my conduit is going right through this direction. Can you guys see? I'm going from 750, so my conduit is going down 40 feet, 10 feet. So we start at 0 here. If we start at 0 feet here, I'm going to end up going up here. I'm going down. I'm going to end up down. My conduit is going to be, the same location is going to be 10 feet down or 10 feet up. So here, 0. If I'm going, no, 10 feet up, 10 feet up in the air. Can you guys see that? Because we're going up. If you start at the same elevation, 0, your conduit is going to go up in the air 10 feet. So these are the things that you have to pay attention, because the elevation is going, we're going down this way, down this way. Any question, guys? That's the only place where the contour line becomes a big deal, really, for us. Conduit, trenching, when we trench. Benchmark, elevations are located. Benchmark is your reference point to all the elevation. Reference point to all the elevation. Established, my friend, at a certain point. I showed you the reference point. Here's the benchmark for us. Our benchmark is 745.68, right here. That's the reference point for all the measurements. How high above that benchmark? Who does it? The surveyors, not you. Responsible for the primary survey of the industrial site. Establish that benchmark, and everything is measured above and below that benchmark. Either the city datum, or most of the time is going to be the mean sea level for the site. Is if we have 750, what's 750? 750 feet above the sea level. 500 feet below the sea level. Anybody knows where the 500 feet below sea level? Brad, you're good with geography. Is it below sea level?
It's below sea level. I don't know if it's 500 feet.
Yeah. Yeah, the Dead Sea, I think is the lowest point on Earth. I think it's 500 or 600 feet above, below, maybe even more, below the sea level. Elevation.
No, it's outside of Australia. It's like,
A point.
yeah, just watch something.
Elevations, guys. Elevations is a big deal for us. Thanks God in the project that you guys have. Ours is 3D. The most important thing in elevation, especially in industrial project, guys, because we're going to have bus ducts now. Now bus ducts are big, guys. You're going to have probably, you're looking, if you have a bus duct, you're looking about probably 8 inches by 8 inches, big duct going all the way, 8 by 8 inches. That's a big chunk of thing to move 50 feet in the building. That's where it becomes elevation is a big deal, guys. Then you have to coordinate between you and all other disciplines. I can't go through a beam. I can't go through a duct. So elevation becomes a big deal, guys, for us. Plans for industrial provide valuable information about the concerning the building construction. Another thing about the building construction, guys, is it a steel building, a concrete building, a wood building, and who cares? Well, that's going to decide what type of wiring system you use. Brad, if you use an MC cable and EMT, you don't even have to worry about that. EMT or an MC cable. The challenge, the people who want to be cheaper. So I have a lot of people. Was it Ryan? Not you, cheaper, but did you ask me about using? You guys were trying. Your company is trying to use Romex in one location, commercial building.
Oh, yeah, it was a commercial building, but with construction.
Wood construction. So for example, can I go cheaper and wire a commercial building if it's a wood construction? Yes, you can use Romix. Who cares? Cheaper. If you want to go at the bottom end of the construction, guys, you can do it lower by using Romix instead of MC or EMT conduit. So the construction type of the building becomes a big deal. Other than that, most of the engineered, so-called engineered projects are EMT and MC, and you don't have any problem with that. Okay, a couple of things, guys. Sometimes the elevation, they will tell you they are 10 feet above the benchmark or 15 feet above the benchmark. So they have the benchmark over here, and they go above and below the benchmark. Just know how to read them. When we have our elevation, here's our elevation here. They actually showing the elevation, guys, right on a 772.5 up to this point. So you can subtract 765.5 from 751.5, and then you find the elevation of this floor, and so forth. So they're giving it to you in this plan. They're giving it to you as an elevation, not as a reference to the benchmark. Invert elevation. Invert elevation, that was on the test. What is an invert elevation? You're going to see it, guys. Indicate the level of the lower edge of the inside of a conduit entering a manhole. So if you have a conduit, the lowest conduit, here's my conduit, that point, guys, here, the lowest point is called invert elevation. Don't ask me why. Invert elevation. The lowest conduit. So if I have another conduit here, a conduit here, and a here, and here, you go to the lowest conduit. The bottom of that lowest conduit is called invert elevation. Invert elevation. Does that make sense? That was on the test. So please remember that one. The lowest, the bottom of the lowest conduit. The bottom of the lowest conduit. That elevation is called invert elevation. So that elevation, let's say 735 feet. And it has to do probably with the water, guys. These manholes, you need to know how low this point is, because at a certain time it's going to be below the water table, could be below the water table, and the water, it becomes a water conduit. So everybody knows how to use this one, I hope so, by now, right? The scale, guys, using a scale, an architectural scale. I hope by now we know how to use the architectural scale. They go from 1/8, 1/4. If you're going from this side to this side, this is 1/8. From right to left, left to right is always half of left to right, one scale, right to left another scale, and the right to left is half of left to right. So here's 1/4. What's half of 1/4? 1/8. If you guys look at one, there you go. So you can be, here's my 1. What's half of 1 is a half. So they have 2 scales on each one of them. Here's 3/16. What's half of 3/16? 3/16 multiplied by half. So 32. So if you guys, these are the scales. I have no doubt that you guys are good with that. Anybody does not know how to use this? There are 2 scales. One of them is half of the other, for a total of 12 scales. Requirements are met. For the site plan, guys, review the plans and specifications. This is from an electrical contractor point of view. Be aware of the requirements, whatever special requirements they have. Ensure that these requirements are met. Advantages should not conflict with site plan being carried out with other trades. So, as an electrical contractor, guys, you can get into a lot of troubles if you don't know what the site plan is, especially with the digging, guys. Trenches, especially if you're going outside. Parking lot, trenches, parking lot lights, trenches, lights bill comes to my mind, and power in to the building, and generators, if you want to put generators. When the generator guy came, guys, they certain cities, they measure the noise of the generators from the property line. So if you decided Spencer, they told you they want generator, oh, no problem, we'll just put them in the back of the building. Well, have you paid attention to the easement and to the property line? You have to go measure from the property line to the generator. Certain cities, guys, allow you certain amount of decibels. So decibels, not decibel, decibels. So the noise pollution, and light pollution is a big deal with major projects, especially if you have generators with noise pollution. So how do you know where the noise pollution is? You have to know the property line. So before you do it, you go do some calculation about the noise pollution right on the plans. We don't pay too much attention to the noise pollution. Hopefully you can catch it before you guys order these. If you don't catch it, almost always, guys, the generator guys will remind you of the noise pollution.
During the construction process, is that something that you do? You have to, you know.
If it's design engineers don't, yeah, if it's a design build, it's really a good idea to solve it before you build the building. So you know what type of generators you're going to put where, how far from the property line to maintain the right noise level.
No, just like in general, you know, there's some built on a building and everybody's complaining in the neighborhood. Is there any way to get around that?
Not them complaining or solve the problem.
Well, because the noise.
Oh, there's solution for that. One solution is erect a wall. Another solution is enclosures, bigger enclosure. They have solution. If you have a problem, they have a solution for it. One of them is cheapest would be erect a wall, but would they allow you to erect a wall between you and them and then block them in? So
Right, but then that's the whole point of zoning too.
yes, but even with zoning, the problem is this area is zoned industrial, but you have a big generator, you don't pay attention to noise attenuation, you end up, even with the zoning, you end up with annoying those guys. So there is a solution, guys. They have a noise attenuation enclosures you can buy. It becomes more expensive. But you should pay attention to this as a contractor, because if you know you are going to put generators outside with a noise attenuation, and you better know what's the allowed at the center point, the property line, so you can buy your enclosure, the cheapest enclosure. You know, there's some calculation need to go. So property lines, I can't emphasize this. Property lines becomes a big deal. Noise attenuation and light spill. If you have hash marks, guys, indicate that the elevation is to be changed. So they're going to change elevation. No elevation shown in dark lines. A couple of things to know. I don't know if we have here. We have the dark lines. Can't remember if we have. If you get you. So they can indicate, guys, the elevation hashed marks as well as the dark heavy lines. So these all these are going to be changed based on that one. This one is going to stay. So there's a lot of, if you guys look at these, the hashed ones, each one of them is going to be changed based on this elevation. Each one of them is going to be changed. Is that what they're okay? Existing contours to change. Yep, there you go. So all these stuff that we showed, the hashed ones, this is indicating that this line is going to be changing. If you have a contour line like this, 450 feet, this is no change in the elevation. No change. How do you change the elevation? Landscape the area. Any question, guys? Any question about hashed lines versus dark lines, no hashed, in terms of elevation? Who cares? You can't, in this case, you can't go put your trailer somewhere in this area, knowing that this area here is going to be actually dug and surveyed. An interesting detail, guys, just FYI, an interesting detail for telephone, 8 feet protection. I want to highlight, I think it's, 18 inches protection underground, conduit PVC. So what is that? We have D is metal conduits, rigid metal conduits for physical protection. E is PVC and changing all the way. So if you're bringing the power, the phone line from the utilities, you need D, rigid metal conduits, physical protection. The same thing could be for the power. Bringing it underground. I could have continued, guys, with rigid, but it's if you're underground, your number one choice is PVC. You switch it to PVC underground to get you full protection from corrosion and so forth.
Well, you know how you pull an underground service to a pole for service or whatever, you would normally just pull it to the pole, they'd run it up the pole for it.
Yeah, but you're gonna put the conduit, so that's a conduit.
You don't go.
Yeah.
You don't go.
No, you don't pull the cable. They bring the cable, but you bring the conduits to them. No.
On the pole.
You will what?
You don't go up, you don't touch the pole.
You say you just stick, you put your conduits right at this point,
Yeah, you
and
leave
then
the
they tie
trench
into it?
open. You leave the trench open so they can.
They can tie it into the existing conduits. The point of demarcation, guys, between you and the utilities, where you're going to stop here, they don't want you to climb on their pole. That's going to be the point of demarcation between you and the utilities. Are you going to stop right at this point to pull it all the way up? You have a point, you don't want to climb on the pole. So they might stop at this point here, cab it, and they come and tie it for you. I see your point. This happened to be a telephone service, guys. It could be the same thing where you can stop right at this point and they come and they continue with it. Any question, guys, about the detail? Good detail for service for telephone. Here's another one, guys. Detail for direct buried cables. I like these details. 24 inches. It's typical. 24 inches typical. Depth above your direct buried cables. Warning tape. When do I need warning tape, guys, in this area? When do I need warning tape? When? Yeah, you can put electrical warning tape right above it. The only location by code you need a warning tape right now if it's a service. Is it a good idea if you bury a cable to have a warning tape that says electrical power, be careful? It's a good idea, but by code it's only required on service, if you have a service. Raceways entering, this is concrete encased raceways. That's really interesting, guys. If you have a 4,000 amp switch here like we would do, Spencer, my friend, if you have a 4,000 amp switch here, this is how most likely your conduit are going to be located. Concrete encased, we did a few of these, concrete encased. And then you can put them, depending on what type, if you encase them in concrete, you can go as low as, look at that, 6 inches. Based on the table, the depth table, you can go as low as 6 inches. If it's rigid, you can 18 inches. If it's PVC, 12 inches. If you encase it in concrete, PVC encased in concrete. So had this been in this case, we have concrete encased are required for certain type of raceways. This is say PVC. Here is my PVC concrete encased. Then my depth over here, I can go as low as 12 inches, a foot. Concrete encased PVC conduit, very common, 12 inches. 12 inches to the top, 12 inches to the top of the conduit, to the top of the conduit.
You need pour concrete around.
Yeah. Yeah. They set them with this frame, and then pour the concrete around it, concrete encased. This is coming, guys, if you have a where would they use something like this? The 4,000 amp switch gear that you guys are going to be having, most likely going to end up with 12 runs of 500. So here's 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So this is a system where you can you build it, encase it in concrete, right? You can design it and bury it at 12 inches. That's a system where you can build in concrete, in PVC, each one of it is PVC. I think it probably 500 kcm to get you the 4,000 amp. Off you go. Any question, guys? I don't know if you guys have seen if there are frames. These come encased in frames, like you see. You can see the frames here, and you set them and so forth, spaced accordingly, and you bore the concrete around them and encase the whole concrete. And you don't do something like this in a 225 amp panel, guys. We're talking about 2,000 amps and higher. A good application for this: services, feeders, and services. If you're using rigid metal conduits, your conduit of choice, guys, for underground is PVC. If you decided to use rigid, make sure it's treated for corrosion protection. For example, you can't use rigid, aluminum rigid underground. You're going to use steel rigid that's treated for corrosion.
Can you use 40 in concrete? Schedule 40?
Yeah, schedule 40 or 80. So, a couple of things, guys, you're going to pay attention. For example, if you have a lot of rocks, large rocks, and you're using, you're going to put large rocks and you're using schedule 40, for example, and you start burying these conduits with big, large rocks, there is a possibility you're going to damage that schedule 40 or 80, as a matter of fact. So, paying attention to when you bury it. There's a whole way of burying it, guys, and so forth, excavation and adding material to bury it. For the most part, guys, as a contractors, if you're in the PVC conduit, underground, schedule 80, pay attention to have large rocks. Don't drop the big large rocks in the trench. We're good to go. I'm not too fond of using rigid underground, steel or otherwise.
Is it legal to use that thing that slices the wire and pulls it down into the ground?
As long as the trencher.
Well, it's not the one that digs it, it's the one that actually pulls it down to in the ground.
Does it meet the requirement of 24 inches? If it meets the requirement to dig it, like if it's direct buried cable, you need 24 inches, and it doesn't damage. It's made not to damage the cable. I don't see why not. Manhole, my friends. Here's the invert point, Spencer. Right here. This is my invert point. If you have a manhole, you have to have a drain. Can you guys see how it drains? The water will come at the end and go back down here, drains. Pull ring, so you can pull your cables. Racks, you can rack your cables as they come in. Manhole cover, and there's a whole manhole requirement, guys, if it's high voltage or low voltage and so forth. So the conduits will come. The reason why we use a manhole, it's a good J box. Think of it as a good J box. My cables are coming from this area here and moving to this area. I have another cable going from here, going that way. So that there's a lot of arrangement. If you do it this way, guys, and you bring in a conduit, a conductor, say 4-aught, then this manhole becomes like a pull box, and you have to apply the rules of a pull box. Because remember, straight pull is 6 times the largest conduit entering that box, plus 8 times the largest conduit. If it's an angle pull, if it's going with an angle, or you pull 6 times the largest conduit here, plus all the other conduits in the same wall, and so forth, as you get into sizing the manholes. There's also a requirement, guys, on, I believe this cover has to be 100 pound or more, or you have to have a key to open it. If you have a transformer inside the manhole, good luck. It moves you completely to a whole different ventilation issues with transformers. If you have a medium voltage, it becomes a whole, you have to go look at the medium voltage requirement. But if you have just a manhole, guys, like this, just to pull cables in it, no equipment, no transformers, the only thing you need to pay attention to, if I want to size this manhole, Spencer, all what you have to do is, this is a pole box, exactly the rules of a pole box. This is a straight pole, 8 times. Suppose this was 6 inches times 6 equal 48, right? 48 inches. So the distance from here to here, you need a minimum 48 inches. That's one size. 48 inches. Minimum. I'm saying minimum. Drainage and the whole big spiel. Lighting standard or standards, you have when you have lighting base. Just a point. I always, you guys, I give you one that you always throw on your detail. You need a base for lighting, at least minimum 3 feet. This is structural, really, not electrical. Nothing in electrical. Is this required by code? Ground rod. Lightning protection. This is your lightning protection. You can protect your, as you tie your pole here and you go up, this will be your lightning protection. So that's basically about it.
Is there
This-
a certain
this
height
one-
that you'd have to, like a standard
Height here?
that would make you have to have both lighting protection?
No. It's a good idea. Well, if you have 30 foot poles, a lot of 30 foot poles. 8 foot, no.
You know what I mean?
Yeah. 8 foot, no. 30 foot poles is a good idea. If you have an 8 foot pole and 10 foot pole, I don't know if I go. And sometimes they go every other one, every other pole. You take the first one, you ground it. And again, this is a grounding rod, guys. The only reason for this one is, the only reason for this rod is lightning. It's nothing to do with grounding. Nothing to do with grounding. Do I need to tie this grounding rod, guys, to the grounding system of my building when I bring the circuit? Yes. But this is mostly lightning. SI system, you guys read it on your own. Measurement. Soft conversion. We always talk about this one, guys. If you have a soft conversion, as you design the system in the standard and then you convert it to metric. You design it foot and you design it in a foot and you convert it to meter. Hard conversion, when you, from the get-go, you design your system based on the metric system. From the get-go. Soft, you convert the measurement. Hard, you design directly in metric. Trade sizes, I want to bring to your attention always, we touched on that one last quarter, guys, too. If you go to a 1/2 inch, look at these. All these are 1/2 inch, but look at the actual interior diameter of them. They're all different. So what is 1/2 inch EMT? It's a trade name. It's not an actual size. So, and that will allow you guys, when you're looking at how many conduits you can fit in 1/2 inch EMT is different than PVC. That's because a trade name, it's just a trade name. It's just a trade name. Flexible is different. 1/2 inch, all of them, look at this, 0.62, 0.5. Rigid, flexible, PVC, we don't have PVC, but intermediate metal conduits, rigid metal conduits, flexible, these are all metallic, non-metallic, here you go. Electrical non-metallic tube, eh? That's a ENT, 0.56. That's the smallest, right? 0.56, and it makes sense if you look, this is non-metallic. Anyway, so that's a trade name, not an actual interior diameter. Mr. Rabab, the only thing I want you to remember is the kilo, 10 to the power, it's 1,000. Mega volt amp. A lot of these are coming in use, guys, in the power industry. The rest of them, the DC and the centi and the milli, read them in your own. Any question, guys? Any question about the site? Any questions? I can't emphasize, guys, the busways is really the key point for the whole deal. I want to remind you, when we talk about, let's say I have a few seconds here. Can you guys go to page 41 in any secret book or article 110, manholes? If you guys go to the manholes, I'm just going to tell you a few things because we talked about manholes. Access to manholes. So if you're designing a manhole, Spencer, it's article 110.75. 110.75. Article 110.75. NEC article 110.75. Let me just read a few of these guys. If you get into a manhole to size it, you have to pay attention to these. It says if you have dimensions, rectangular access opening shall not be less than 26 by 22. The opening for the manhole, regardless of what you calculated, you have a minimum. If you have a round, it can't be less than 26 inches. If you have a round, 26 diameter, 26 an inch in diameter. That's the entrance to the manhole, with some exceptions for low voltage. Location: the manhole opening shall be free of protrusions and could injure any people or prevent readily access. Location: you can't put that cover right above the equipment. The cover has to be 100. Cover shall be over 100 pound, or you have to be able to open it with a key and mark it. You have to mark it with electric. So there's a few requirements, guys. Bending spaces, equipment working space, if you have equipment. If you are, and it'll make a manhole, guys. If you have a manhole that you're going to put a switch gear in it, well, guess what? A switch gear 480, which they do in downtown Minneapolis. You have a manhole with a big switch gear in it. Then you have to look at the clearances, working clearances, in front of a switch gear. But if it's just manhole for conduits, all what you have to do is just the rules of the bending, the pull boxes rules. Pull boxes
With
rules.
the switch gear, they do plates on them on a sidewalk or something.
The ones that they do underground in downtown Minneapolis, all these underground tunnels, they have switch gears and they have everything that you can imagine with special requirements. So that's a thought. Manholes, guys. A few things to remember: strength and cable workspace. A clear working space not less than 3 feet wide shall be provided where cables are located on both sides. Look at that, on both sides. So regardless of your calculation, if I put my cables, guys, on both sides, I have to have at least in the manholes, I have to have at least 3 feet between them. Working space, no equipment. So anyway, if you get into designing a manhole, please pay attention to a few rules in the manhole section. Any question, guys? Any questions, my friends?